Hi, today I will present about the Gesture-Controlled Robotic Arm for Internet of Things project. I will talk about the project background. So, in many industries, robotic arms perform tasks that are repetitive, dangerous, or usually require high precision. So, traditionally, we control these arms. We usually need joysticks, buttons, or programming path, which can be complicated for beginners. So this project explores gesture-based control, which allows user to control a 4DOF robotic arm with hand movements. We will use flex sensors for arm and gripper movement and an MPU 6050 for the base rotation. The goal is to create a system that is real-time and also low-cost, ideal for learning embedded system. So the component requirements are one Arduino Uno, two breadboard, four servo motors, two 10K ohm resistor, some jumper wires, four batteries, two flex sensors, one MPU 6050, and one temperature and humidity sensor for gesture control robotic arm. So first of all, these two servos are controlled together with the first flex sensor, and the second one is controlled by the second flex sensor. Since these two servos are used for elbow and shoulder, so they will move together. And the third servo will be used for gripper control, which is close and open. So I can move them and control them individually. I also added a temperature sensor to control the heat of the servo. So this is a safety measure. If the servos are overheating, it will stop automatically to prevent burning. And the serial monitor will show overheat movement stop. And I cannot turn the servo on anymore. So if I return the temperature to original state, it will start moving again. Okay, so as for the code, I will start initialize the pins that will be used. And this one is for calibration, since I don't want the servos to move randomly and cause damage. So this is the code for the temperature sensor to check for safety issues. As the code for arm control and gripper control, it detects how much the users bends their hand. So basically, if the sensor is reading from the mapped angles of both shoulder and elbow servos, it allows the bending of the hand move forward to raise the arm or strengthen it to lower the arm in real time. So right here, we use the map function to convert the sensor values into angles that the servos can understand, while the constraint function ensures that the servo never exceeds their physical limits. So this actually prevents potential damage. So the gripper is controlled by separate flex sensor, which is A1 pin. It will map the finger bending to the gripper. So it will control open and close, and again using the constraint for safe operation. And during the testing, the servo will print the readings and servo angles, which will help to calibrate the system and verify the movement changes. Okay, right now I will be showing the MPU 6050 simulation. So first of all, this one is the wiring diagram for the base rotation in the 4DOF robotic arm. Okay, if I change the value Y for acceleration, as you can see, the servo motor is turning. So I will use the Y value to control the base rotation. And the serial monitor will print the output too. So how the code works? At first, I will define the library and also the pins that will be used. Okay. So as for here, The NPU 6050 will detect the tip of the sensor along the y-axis. So the sensor reading is amplified and also mapped to the servo angle. This allows the base to rotate left or right according to the hand, or we can say the platform movement. So I also use the constraint function over here. This is for ensuring the base servo to stay within its safe mechanical limits, so it won't overturn. This real-life and real-time tip base control will allow the base to respond smoothly to the movements that we make. So this one will provide a natural rotation. We don't have to control it manually using joystick or anything else. And this serial monitor is used to test and debugging, so we can observe the tilt values corresponding to the servo angles.